All right, so we are going to talk about how to graph exponentials. Couple of reminders before we jump too far into the lesson. I just want to remind us kind of how exponents work. If we have something like 2 to the third power, what that really means is 2 times 2 times 2. Notice we have 3 2's because we are raising to the third power. 2 times 2 times 2 is 8. If we go down to 2 squared, same idea, becomes 2 times 2, which is equal to 4. We have 2 2's because that's how many that the exponent told us to do. 2 to the first, however, anything to the first power becomes itself. Another very important thing to remember is that 2 to the 0 power becomes 1 every single time. That is always true. Any number raised to the 0 power becomes 1. We have yet to talk about negative exponents, at least this year. If we keep the pattern going, where we divide by 2, divide by 2, divide by 2, it follows to reason that to find 2 to the negative 1, we would also continue to divide by 2, meaning we are going to take 1, divide it by 2. A big idea for this new lesson is this. Negative exponents become fractions. So, keep going one more. 2 to the negative 2 would be 1 over 2 squared, otherwise known as 1 over 4. 2 to the negative 3 would become 1 over 2 thirds, 2 to the third, which is 1 over 8 as well. The pattern continues. Divide by 2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. Now, if we were to graph an exponential, you'll notice you have a handy-dandy little table for this on your assignment. We can simply just plug in various values for x, meaning for our first value, we could just go ahead and go 2 to the negative 2. I'm taking the negative 2 from right here. That's going to become 1 over 4. To plot the point negative 2, 1/4, I'm going to go over to negative 2 in the x direction. I'm going to rise 1/4, just slightly above the x-axis, because we haven't quite reached 1 yet. That's kind of where that's going to be. Our next one is going to be 2 to the negative first, which is 1/2. Which is slightly above 1/4, but not quite to 1 yet. Anything to the 0 power is going to be 1. So our y-intercept, or where it crosses our y-axis, is going to be 1. 2 to the first is simply 2. Oops, sorry. We're going to go up to 2. And 2 to the second power is going to be 4. All right. We're going to assume all functions stay are continuous, meaning you should connect all dots. And we should draw little arrows at the end of our graph to say that it's going on forever. Another very important feature of exponential graphs that we've yet to talk about is a new word called an asymptote. An asymptote is a horizontal line for our purposes right now that the graph gets infinitely close to but never crosses. The asymptote in this particular case is basically going to be on top of the x-axis. And here's why. As we get our fractions, those fractions are going to get infinitely smaller but never quite become 0. So for example, 1 over 1 million is a very, very small fraction, but it's still bigger than 0. So say we had, say, x is equal to negative 100. Our f of x value would be 1 over 2 to the negative 100th, which is a very, very number that's, it's a very, very small number, very close to 0, but it is not quite 0. So that creates an asymptote. It's going to get infinitely close to the x-axis, but it never gets to cross it. I want you to draw in your asymptotes as dotted lines for every graph for the rest of this unit. So draw in asymptotes. We're also going to add one more vocabulary word. Notice, I would describe this graph as increasing. As I look at it from left to right, our graph is going up. It's increasing. We're going to call this on an exponential graph growth. So go ahead and label this growth. Let's go ahead and do another example. We've got 1/2 to the x. We can go ahead, we'll just put in the same x values that we used before. But this time, we're going to establish our growth, or decay. Sorry, back up, we haven't gotten there yet. Let's just go ahead and plug in each of our x values into our new function. So we've got 1/2 raised to the negative 2 power. Is it acceptable to have to use a calculator here? Absolutely, that's just fine. If you need help learning how to do this with a calculator, I'm happy to show you when I am back. 1/2 to the negative 2 power is just going to become 4. 1/2 raised to the negative 1 power is going to become 2. Anything to the 0 power is going to be 1. Anything to the first power is always going to be itself. And 1/2 squared, 1/2 times 1/2 is going to be 1 over 4. So we can go ahead, plot those points. I go over x to negative 2, and I'm going to go up 4 to 4. We go over to negative 1, up 2. Anything to the 0 power is 1. Anything to the 1/2 power is going 1 to the 1/2, and then 1 to the 1/4. We can go ahead and connect our dots here. Everything we're going to be doing for the rest of this unit is continuous. And there is our graph. Once again, we have an asymptote. In this case, the asymptote, once again, is the x-axis. We're going to get infinitely close to that x-axis, but we're never going to cross it. Now, there are moments when it's not at the x-axis, and we will talk about how to find those in a minute. This one, you'll notice that as we go from left to right, as I'm looking at it from left to right, I'm noticing the graph is going down. Another word we could use for that is decreasing or decay. All right, pause the video. Finish the first page. Once you're done with the first page, unpause the video and we'll talk about the second page. All right, on the second page, we are talking about how to sketch these graphs. I'm going to just teach you how to sketch in an exponential without having to create a table every time. I trust that you know at this point how to use a table if I ask you to do so. But sometimes it's helpful to just get a general idea of what these things look like without necessarily doing every step. Now, we talked about the generic form for an exponential being f of x is equal to a times b to the x plus c. Now, a couple of very important things that you need to know. To determine if it's growth or decay, you're going to look at b. Growth is going to have a b value that's bigger than 1. b is bigger than 1 is growth. Decay is going to be between 0 and 1. We could write that in symbols to look something like this. This will not work if b is 1, because if 1 squared is 1, 1 cubed is 1, 1 to the fourth is 1, it just doesn't work as an exponential one way or the other. And if b is negative, it runs into some interesting things. I recommend trying that on Desmos and just seeing the pattern that you'll create. It might even give you an error message because it doesn't quite work when b is a negative number. So to determine if it's growth or decay, you'll look at the b, okay? The next thing you need to know is where your y-intercept is. Your y-intercept every single time is going to be at a plus c. Your y-intercept is going to be where it crosses the y-axis, and it's always going to be at a plus c every single time. The reason is anything to the 0 power is 1. So a times b to the first plus c becomes a times 1 plus c. So I lied. Back up. Let's try that again. Anything to the 0 power is 1. I mixed up the numbers. So a times b to the 0 plus c is equal to a times 1 plus c, which is just a plus c, which is going to be our y-intercept every single time. And the asymptote is always going to go through c. So if I want to sketch a graph of something, for example, if we had an equation like f of x is equal to 4 times 3 to the x plus 1, I could sketch a quick graph and have a general idea of what this is going to look like without too much difficulty. First, is it growth or decay? I'm looking here. I see that 3 is indeed bigger than 1. So I'm expecting the graph to look something kind of like this shape. Okay? I can see our y-intercept is going to be 4 plus 1, otherwise known as 5. So I'm going to go up 1, 2, 3, 4, 5, and that's where it's going to go through the y-axis. I also see that we have an asymptote through 1. So I can go ahead and put in my dotted asymptote, knowing that it's never going to go past 1 because we are shifted up 1 unit. So growth is going to follow this pattern through 5, never going to go past 1. The last 2 pages are simply graphing in a linear fashion. If you need help, please talk to me later. Talk to each other. Do your best to figure it out. Have a good rest of your day.